LeetCode. Problem 13. Roman to integer isn't just about ancient symbols. It's a modern exercise in parsing structured input. Think of systems that read compact symbolic data, like configuration files, telemetry streams, or mini-languages. But Roman numerals throw us a curveball with subtractive notation. That's where simple strategies start to stumble. It looks easy, but it takes precision. Let's turn these old-school symbols into clean, reliable code. All right, ducklings, let's dive in with our first idea, a good old brute force pattern matcher. We'll waddle through the string one flap at a time, checking known patterns directly. Let's watch how this plays out in code. First up, we build a map of all Roman symbols to their values, including special combos like IV and CM. This lets us grab values fast while parsing. With the map set, we drop in a pointer to track position and a total to build up the result. We'll scan the string from left to right. At each spot, we'll check if we're looking at a two-character combo or just a single numeral. To do that, we peek one character ahead. If the current and next form a valid subtractive pair, we grab its value and jump ahead 2 steps. If it's not a special pair, we treat it as a standalone character, grab its value, and move ahead by 1. Once the string is fully processed, the total holds our final result, the integer version of the Roman numeral. This runs in big O of n time, up to 15 steps max, and uses constant space for the map. It's readable and handles all cases, but checking pairs repeatedly adds clutter and invites subtle bugs if we're not careful. So how do we clean this up? What if we flipped direction and used past context to detect subtraction? Let's try scanning right to left to simplify the logic. We begin with a fixed map of Roman symbols to integers. Since these values never change, a static setup works perfectly. Then we set up 2 numbers, one to hold our total and one to track the largest value we've seen so far, starting from the rightmost symbol. By scanning backwards, we can easily tell when a small value comes before a big one. That's our subtraction trigger. Inside the loop, we grab the current symbol's value using our map. If this value is greater than or equal to the max so far, we add it. It's either part of an additive group or kicks off a new one. If it's smaller, that signals a subtractive pair, so we subtract it from the total. Once every symbol is handled, the total gives us the final integer result. This stays in big O of n time and O of 1 space. But now, our logic's tighter. We avoid explicit pair checks and rely on clean numeric comparisons. That makes the code easier to maintain and harder to mess up. Let's push for even more clarity with a forward scan that leans on greedy logic. Instead of checking pairs or tracking history, we make decisions based on what comes next. We kick things off with a simple map from each Roman symbol to its integer value. Constant time lookups every time. Next, we set up a total to accumulate the result as we pass each symbol. We'll loop left to right across the string. At each step, we decide to add or subtract the current value, based on a look ahead. We grab the integer value for the current symbol. That's our base for the next decision. If it's smaller than the next symbol's value, we're in a subtractive pair, like I before V, so we subtract it. Otherwise, we're in a normal case and simply add the value to our total. Once we finish the scan, the total gives us the full integer value of the Roman numeral. This final method is slick and fast. Big O of n time, constant space. The greedy look ahead is clean, easy to follow, and ideal for interviews or real-world passes that demand speed and clarity. We started with a pattern matching brute force, easy to write, but clunky with pair logic. Then we reversed direction, subtracting smartly with a backward scan. But the real power move? A greedy forward scan that uses look ahead. No extra checks, just clean math. This isn't just the fastest, it's the cleanest. And it mirrors techniques used in real systems, from compilers to log parsers. Sure, you can get fancier, but for interviews, this is the sweet spot. Clear, correct, and quick to code. Try applying this scan pattern to other parser challenges. You'll be surprised how often it works.